Hello, this will be the tutorial for the interpolation search. So when we say interpolation search, that is a efficient search algorithm for finding a specific value within a sorted array, mainly when the array elements are uniformly distributed. So that means to say here, in interpolation, we actually um, sort a specific sorted array already. It improves upon binary search by estimating the likely position of the target value rather than constantly checking the middle element. It is a fast search algorithm for sorted, uniformly distributed arrays and suitable for non-uniform or unsorted data, where binary or linear search may be preferable. In this case, right now, um, it is guessing, interpolation guesses where the sought value might be based on the actual value of the key, assuming that your array is sorted and uniformly distributed. So right now, this algorithm calculates a probe position as well, using the values at the current low and high indices. In the current value, the probe position is estimated using that following formula. So there will be a position calculation, whereas there will be you'll calculate the low position, high, and do minus to the low times to the target minus the array long. So the array high is all divided by the array high, then minus with the array low. Given that the low and the high, that is the high element, the high index and the low element. If that is array low, that is the, I don't know what we call this one.
I
The high
hate
is
this new
a
kid. Oh wait,
specific
I have that.
index number. But for the array low and array high, that is the given element already. And for the target, that is the number that you are searching with, the element itself. So where the, as what we mentioned, as the low is the lowest index of the current search range, and the high will be the highest index of the current search range. And array low and array high, that is the values in those specific indices, is what I have stated earlier. And the target, the value that you are searching with. And right now, this will be the steps that you are following in this particular interpolation search, whereas you will start with a sorted array, set initial boundaries, and before starting with this with a sorted array, make sure that your array is sorted in ascending order. Otherwise, interpolation search becomes a confused squirrel in traffic. That is to say, it will be horrible for you to work on that one. And for the setting initial boundaries, you have to define low and high indices in order for you to integrate that in the formula that was given earlier. And afterwards, there will be here a the third particular steps, which will be while value is within bounds, you have to continue while a row is low, or well, a row low if it is less than or equals to the x, or less than or equals to the array high. You have to because if the target isn't within those values, it's not in the array. Bail early doesn't waste time. So in this case here, if you wasn't able to get that one, if the value is within bounds already, you have to stop the iteration or the searching, since you cannot it does not ensure that you could be able to search those item, or that element in your given array. Now you have to estimate the position. For estimating the position, you have to definitely apply the formula for the position and low that was stated in there. And afterwards, you will definitely um, check estimated position. For searching the estimated position, check if array the position, if it is equals to the target, you may simply return target is found. And if array is less than x, this will be the route that you will also follow. You have to move right, and for your low, you have to definitely the position of that make you need to add one, iterate one, and if your array position if it is greater than the x, you have to move left or high, you have to deduct into one or decrement into one as well. So definitely here afterwards you have to repeat or return, loop back and repeat steps 3 to 5 until the value is found or low if it is greater than a high or the target is out of bounds. In this case, you have to return -1. If you wasn't able to find that specific target right there, you can easily um, display -1 as the that specific data or I mean element is not into your um specific array. Now, afterwards, since you were able to repeat and return already, those are the given steps that you have to follow for the enter implementation. Afterwards, you will definitely, I mean, the time and space complexity, we will also deal with that. For the time complexity, best case for that one is given here is the own notation of logarithmic event. So that is logarithmic and the logarithmic scale as when the data is uniformly distributed, interpolation search can be highly efficient. It performs a binary search with a more intelligent guess for following position instead of splitting the array in half each time. It estimates where the specific value should be located. And in this case scenario, the array is actually evenly distributed and the probe positions give you the correct answer almost immediately. In this case, absolutely, in one searching, you were able to find already the location of your target in one search directly. Now afterwards, the average case. And for the average case, this is absolutely the same thing, a logarithmic and logarithm scale as well. When the data is uniformly distributed, I mean, I'm so sorry, that is for uniformly distributed data. This is because interpolation search still uses the same concept of narrowing down the search area quickly, even if you don't hit the target in the first guess. So it will really, it will not take a long time for you to be able to check where is the location of that given data that you're searching with actually. Now, afterwards, the worst case time complexity of interpolation search. This is um linear time. If the data is not uniformly distributed, like the values are clumped together in some sections and sparse in others, the interpolation formula may make poor guesses and lead to linear searches. In this case, the search may degrade into a linear search where you need to check each element individually, which is a linear time complexity. So in the worst case scenario, it happens when the data is skewed actually, and the interpolation formula doesn't help you get closer to the desired value. So it always takes logarithmic of n times in all cases, even in the worst case. It search I mean it outperforms binary search in best and average cases when the data is uniform, but can be much slower in the worst case when the data is not uniform. Now for the space complexity for this one, meaning it only requires constant space. The algorithm only needs a few variables, low, high position, and X the target. Doesn't require any extra data structures or array to be allocated. So therefore, its space complexity is constant because there will be no additional spaces required besides the variables to track the search bounds in the target. So that is that is the definition of the steps that we are taking, as well as the what we call this one, the time and space complexity of this particular search. Now, in the next video, I'll be going to illustrate the example for this one. See you there.